Hello everyone, welcome back to the second video of remainders. Till now we have covered uh, quite a few questions and also we have read about the remainder theorem. Just to do a quick recap of what we have done in the last class, we started with what exactly is a remainder. We understood what a quotient is and what a divisor is, right? Now, if a number is completely divisible by a divisor, then we can say that remainder is 0 or there is no remainder. If it is completely divisible, if the number is not completely divisible by the other number, then we will say there is some remainder left, right? Remainder left. Now we have seen this question 15 into 22 into 21 divided by 99. We try to extract 99 from it if we can. When we were able to extract 99 from it, we can say 99 divided by 99 is 0 multiplied by anything that is going to give us 0. So this means if you are able to take out 99 from that number, given number, then that complete number will be divisible by 99. Then we have seen remainder theorem. If a number is given in the form of addition of 3 or 4 separate numbers or multiplication, you can use the remainder theorem. Rather than doing addition or multiplication, use separate remainders, then multiply or add them as per the requirement of the question. Note, this is only applicable in the case of addition, subtraction and multiplication, right? Then we did this example where we use remainder theorem and we also understood how the remainder pattern works. As I have shown you, in case of 1991, we had a remainder of 3. Then 1992, that is 1 more, will have a remainder of 1 more, 4, 5, 6. When we got the remainder as 7, we know 7 is already divided by itself. So that will give us 0. And if you note here in this case, what we have learned in the negative remainder part, as I told you, we can write that 7, we can write it as 0 as well. You can see, as I already told you, we got 7 here. You can add 7 in it, means you can add the divisor in it. This divisor, add divisor in it or subtract divisor from it. All the cases are going to be the same. So in the case of 7, 0, 7, 14, 21, all are the same remainders. This one was clear. Then I've told you this question we did it from using that method where we were able to extract 64 out of it. Then I have told you that 96 question is another topic altogether which we are going to cover in the next video. That is what we are going to cover in this video. Just stay with that. Then after that we understood the concept of negative remainder. That means if in case a number is divisible by 1, you can add that remainder 7 in that remainder of 1, and so 1 is equivalent to 1 plus 7 8, or 1 minus 7 is minus 6. Minus 6, 1 and 8 plus 15 all are the same remainders, right? So that is why we can also have a negative remainder. In this question, we understood the application of negative remainder. See, 7 raised to power 21 divided by 50. If you had gone with a positive remainder, this question was unsolvable. You cannot do 7 into 7 into 7 in your copy and then finally divide it by 50. No. What we did, we just recall that 7 into 7 is 49, which is very close to 50. So why not write 49 as minus 1? 49 and minus 1 are the same remainder. So minus 1, minus 1, minus 1 and so on, and we have solved this question in this form. Today we are going to solve this question as well. Let's start with this question only. What is the remainder when 3 raised to power 444 plus 4 raised to power 333 are divided by 5? Now first let's see 3 raised to power 444. So 3 raised to power 444, can we write it as 3 into 3? Why 3 into 3? 5 to the 10. So it is coming somewhere around that. We will see. Just for now, 3 into 3, 3 into 3, and so in the pairing of 2, we'll have to form 2 groups. I hope this part is clear. So 3 into 3 is one group, another 3 into 3 is another group, another 3 into 3 is another group, and so on. We can have two groups in this format. Now let's only focus on 3 into 3 part. 3 into 3 is going to give me 9. 9 divided by 5. What is the remainder I will get? I will get a remainder of 4. So if I put 4 here, that will shorten. If I put 3 instead of 3, I will put 4. It will be 4 into 4 into 4, 222 times. 222 times. Has question got easier? No. What we are going to use? We are going to use the concept of negative remainder. Now tell me, if the remainder is 4, can we not write it as 4 minus the divisor, that is minus 1? This means write 4 or minus 1. Both are the same things. So as I have written 4 into 4 into 4, I can also write as minus 1 into minus 1 into minus 1, 22 times. So this means minus 1 raised to power 2 times. So this means that this is going to give me a final answer as 1. Minus 1 raised to power even power is going to give me positive power. Minus 1 raised to power odd power is going to give me a minus 1. This part is, I hope this part is clear. This is part number 1 of the question. Now part number 2. I have to divide 4, 3, 3, 3. Now just start with the counting. 4, first part. We can if see there are two ways to do this question. I can write it as 4 into 4 into 4, 3 times. What is 4? When 4 is divided by 5, it gives me a remainder of 4. I can say it is 4, or I can subtract 5 out of it, and it is going to give me minus 1. Is it clear? Minus 1. I hope this part is clear. Either I can write it as 4, or I can write it as minus 1 into minus 1 into minus 1. How many times? 333 times. So this will be minus 1 raised to 3 times. So a negative power of 1 raised to power odd power is going to give me minus 1. I hope this is clear. So we are getting minus from 1 from here. We have got plus from there. So 3 raised to power, I will write it 3 raised to power 444 plus 4 raised to power 333 divided by 5. 3 raised to power 444 gave me remainder of minus 1. So no, 3 raised to power 44 gave me remainder of plus 1. The 4 raised to power 33 gave me remainder of minus 1. I can do minus 1 this by divided by 5, and I have got an answer of what we have got? We have got 0. 0 is the answer of what we have got in this question. I hope this part is clear. Now let's move to the next question where we have left, and just this question, 2 raised to power 96 divided by 96. Now let's see 2 raised to power 96 divided by 96. This is a question of concept. We are going to use the concept of common divisor, right? So write again, 2 raised to power 96 divided by, how can you write 96? Can I not write it at 2 to the 4, 4 to the 8, 8 for the 32, 32 into 3 is 96. Is it clear? 8 for the 32, 30 into 3 is 96. So can I not write it as 8 into 4, means 2 into 2 into 3. So did I get 2 raised to power 96 divided by 2 raised to power 5 into 3? What do you get? 2 raised to power 96 divided by 2 raised to power 5 into 3. I hope this is clear. Now subtract whatever you want. Simple division. 2 raised to power 5 and 2 raised to power 96. Can I not remove 5 2 from the numerator? Yes. So 2 raised to power 91 divided by 3. I hope this part is clear. What we have done? We have removed 2 raised to power 5 from denominator and 2 raised to power 5 from numerator. So we are left with 2 raised to power 91 divided by 3. The only thing you have to make sure, just make a locker over here. This, let's call it a locker, and put 2 raised to power 5 here, which we are going to use in the end. For now, 2 raised to power 5 is safe in our locker, right? Now do the simple calculation. This is 2 into 2 into 2 into 91 times divided by 3. I will do a grouping of 2 each. Why? Because I know 2 into 2 is 4. I can get a remainder of 1 or minus 1. Always remember, in a given question, try to get a remainder of 1 or minus 1. That is going to simplify the question for you a lot. Right? Now let's see. Here we have 2 into 2, 2 into 2, 2 into 2. So if you have done the grouping of 2 and 91 2s are there, so will not be there 45 groups of 2 into 2 plus 1 separate 2. Multiply of 1 separate 2. So this means 45 groups of 2 and 1 separate 2 nearby. So this group 2 into 2 is 4. 4, how many times? 45 times by 3 multiply by 2, which is separate. So 4 divided by 3 gives you a remainder of 1. 45 times into 2. So all the 1 are multiplied will give me 1 into 2 divided by 3, and you are getting remainder of 2 from here. I hope this is clear. Simple remainder theorem, and the use of we have used the concept of negative remainder. Means always try to get remainder of 1 or minus 1, and that is going to be simplify your equation. So 1 into 2 is 2. So our final answer is, remainder we have got here is 2. No, the question is not complete here. The question I have already told you, put whatever you have divided in the start, 2 raised to power 5 in a locker. Now time to take out 2 raised to power 5 from the locker. So our final answer is 2 raised to power 5 multiply by remainder of 2. That is 2 from this part, right? And so we are getting what? 32 into 2. So the 64 is the final answer. A and S. Final answer is 64 and not 2. In case of common divisor concept, always multiply it back with the common divisor you have used in the start. What was the common divisor? 2 raised to power 5 we have used in the start. Multiply that with the final 2, and that is how you will get the answer. If you have not followed, if you are confused in this concept, there is a PYQ on this in this sheet only. I will when we will do that, this concept will be more clear. Right? Now let's move to the PYQs. We have to do 2 PYQs today from 2020. This is the first one. If you have not done this, I will ask you to download this from the channel. Try to solve them on your own first, or you can pause the video here. Try to solve them on your own and then check and then only proceed to see the solution. Now tell me, what is the least 4-digit number when divided by 3, 4, 5, 6 leaves a remainder of 2? Now, first thing, see, in this question, there are 2 things which you have to know. See, first thing is, there is always a long way to do this question. Finding a least 4-digit number. This is always a long way to do this such type of question. But in exam, when we have limited time, always be smart. Right? Suppose if 2 options are given, 999 and 1002. Without solving, if the statement remain the same, what is the least 4-digit number when divided by 3, 4, 5, 6 gives me a remainder of 2? Now just give me a common sense. Is this a 4-digit number? No. Then 999 is not the answer. I hope it is clear. Now 1003, 1004 and 1002 are given to you. These are the 4 options. 999 is already gone. 2, 3, 4 are given. Now the option you have to pick, which is the best option even without solving. Which option has the best chances of getting being the answer? See, they have told you 4-digit number, all are 4-digit number, but least. So if I have to take a guess of all these numbers, which is answer, I am going to go with the least of these numbers, which is also a 4-digit number. So I will say this could be the answer. If this is not the answer, 1003 I will check next. Then only I will go for 1004, because I have to check the least and also 4-digit number. Now, if these numbers are given 1012, 1022, 1122, 1222, all are 4-digit number, I have to find the least number. So always start with the least to check. Now 1012. Now 1012 I am checking by 3, right? This question is simple. 339 11 339. Then it will be 22. Then 37 21. This give me a remainder of 1, right? So this gave me a remainder of 1, but they ask you when divided by 3, it should give me a remainder of 2. So first option is surely not there. Now let's move to the second option, 1022. Now divided by 3, 3 3 9, 1 2, 12 2. So we have got 0 2. 2 is the remainder we have got with 3. Now we can also check with 4. 4 to the 8. 4 to the 8. 22. 4 5 is 20. 22. 4 5 is 22. This with 4 it is also giving remainder of 2. With 5 we can check 1022. 5 2 the 10. 2 0. 22. 4 22. 5 is the answer. With we are getting 22 as a remainder. Yes. 1022. Can it be 6? 6. 6. 6 1 is 6. 42. 6 7 is 42. 2 0 2. This means we are left with remainder of 2. Do simple division and you will see you are getting 2 2 2 with all the 3 4 5 6, right? So this is the answer. Now mind you, 1 2 2 2 could also be the answer. 1 1 2 2 could also be the answer. 1 0 2 2 is the answer. These all three could be the answers. But we just have to make sure in this case only pick if we have got all these correct, means everyone is giving a remainder of 2. We have to pick the least 4-digit number. So least is 1022 out of these 3, right? Now hope this is clear. Now the last question, this is given 51, 27, 35, 62, 75 divided by 100. What is the remainder? Now first thing, try to extract 100 from it if you can. 100 from it if you can. You understand? If we are able to extract 100, that means it is going to give, it will be completely divisible by 100. Then it will give me an answer of 0, right? Try. So to get 100 in the numerator, we need 25 into 4. That will be 100, means 5 into 5 into 2 into 2. I hope this is clear. Try to extract 2 5s and 2 2s, and that they all will form 100. Now let's see. 51. Can we extract anything 5 or 2 out of 51? No. Right? So this is not helpful in our case. 27. 27. We cannot take 5 or 2 out of it, so no use. In 35, we can have 5 into 7. So there is 1 5 here. Right? So in 62, we know 2 into 31. No, 2 into 31. So 2 is here. And 75 is 5 5 3. I hope this is clear what we are trying to do here. We are trying to find as much 5 and as many 2s as possible, right? So now this is 551 into 27 into, I'm just writing all those bracket numbers separately. 31 into 3 into 5 into 2 into 5 into 5. Now tell me, is it possible to make 100 with 3 5 as 1 2? No. we need 5 5. Oh sorry, we need 2 5 and 2 2, but we don't have 1 2, so we cannot extract 100 completely. So we cannot extract 100 completely. Can we not write 5 into 5 into 2 into 2? We will not be able to extract 100 completely. So that first method is not applicable here. Which method will be applicable? Common divisor method, which we have done in the start of the video. So 5 5 gone, 5 5 gone, 2 2 gone. So separately make a locker and put 5 into 5 into 2. Just keep it separate for now. Right? Now we are left with 51 into 27 into 7 into 31 into 3 into 5 divided by 2. Right? I hope this is clear? Right? So now this is what we have got till now, which we are left with. Now we have to check the remainder of it with 2. See, the remainder with checking with remainder of 2 is easiest. If the number is even, again, if the number is even, 2 will completely divide it and the remainder will be 0. If the number is odd, then the remainder will be 1. Right? You can check it if you want. Then simply, if 51 is divided by 2, the remainder will be 1. If 27 divided by 2, remainder will be 1. 7, 1. 31, 1. 3, 1. 5, 1. So 1 into 1 is 1. 1 is the remainder which we have got here. Now, time to take out the things we have put in the locker, which is 5 into 5 into 2 multiply by this 1 which we have got from here. So this is 5 into 5 into 2. 50 is the answer, and this is give us option number A. I hope this is clear. So these PYQs were completely based on what we have read in the theory. Check the last video. Now try to do PYQs on your own, and mind you, this remainder topic is a little tricky on the difficult or on the hard side. So practice is going to help you a lot in this section. There is no alternate to practice for remainder. There are not many formulas. You just have to remember that remainder theorem and one trick. Always try to make it 1 or minus 1 however you can. And that concludes the remainder topic. We have completed the PYQs, and thank you and best of luck.